Number 49. A hot air balloon is rising upward with a constant speed of 2.5 meters per second. When the balloon is 3 meters above the ground, the balloonist accidentally drops a compass over the side of the balloon. How much time elapses before the compass hits the ground? We are asked to find time, t. So, like always, step 1 is our picture. Here is our ground, and we have a hot air balloon that is rising upward with a constant speed. I'm going to call that V1 this time, of 2.5 meters per second. I'm going to start my step 2 knowns simultaneously. V1 was. Now, before I write, I just want to emphasize that we know that it is going up, and we are told the speed 2.5. I'm going to say that up is our positive direction, okay? This is going to be really important in this problem. I want you guys to keep that in mind. So, since the initial velocity is positive and is going up, it's going to be positive 2.50 meters per second. Okay, and when the balloon is 3 meters above the ground, so I'm going to make this x, xy, doesn't matter. It's just displacement. X is 3 meters. The balloonist accidentally drops a compass. That is going to be our compass. And it's going to fall down here. And we're asked to find how much time it takes. So the tricky part of this problem is understanding how this compass moves with this hot air balloon when it drops. So you think, well, since the compass is dropping, it doesn't have an initial velocity. Like, you would think it's a free fall, but it's actually not a free fall. Since this compass was moving with the hot air balloon previously, it still has that upward initial velocity of v1. So that is the concept of this problem. And one more thing we know is that we have acceleration going downward. We have gravity. So we also have a gravity, and it's going downward. So we're going to say it's negative 9.8 meters per second squared. And our unknowns, we don't know the time. And that is what we're asked to find. So, oh, sorry. Okay, step 3, our equations. We have V final equals V initial plus AT. Distance equals VIT plus half of AT squared. And V final squared minus V initial squared equals 2AX. Okay, let's try and see which equation we want to use to solve. We're asked to find t, so I am automatically not even going to look at number 3. Doesn't have t in it. So let's look at number 1. V final. What is this V final in our story? That is talking about what the velocity will be when the compass hits the ground, because this is going to be like our final. And this right here is our initial. So do we know the velocity when the compass hits the ground? No, we don't know that. So I don't think we can use number one. I'm going to look at number two, the displacement. I do know what the displacement is it traveled from here to here. It was 3 meters, right? The initial, we do know that it was traveling initially upward with the hot air balloon. T, that is the value we are asked to find. And acceleration. The only acceleration in this problem that we have is the gravitational acceleration going downward. So I think we can use number two. I'm going to rewrite it. So x equals v1t plus half of at squared. And you know what, let's put in our numbers right now because that part's a little tricky. Our displacement, we go from the initial to the final. We are going downward. That tells me that for our displacement, it's going to be negative 3 meters. If it was just 3, that means we'd be going up, and that is not the case. We are going down. So x is going to be negative 3. The initial, that was the initial speed of the hot air balloon, and it's going upward, so it's going to be positive. It's positive 2.5 t plus half of acceleration is gravity going down, so it's negative 9.8 t squared. And we are asked to solve for t. Ugh, that's not pretty. I'm gonna first simplify this, maybe. Negative 3. I don't know how to solve it. I'm just kind of doing it as I go. So what would that be? 4.9? I hope so. Okay, and we want to find t. This is it called a quadratic equation? Because we have a t squared. So I'm going to move all of my numbers onto the same side of the equal sign. So I'm going to move everything. I hope you guys can follow. T squared minus 2.5 t minus 3 equals 0. And we want to solve for t. There is really no easy way to do that except use the equation. What is it called? X equals minus b plus minus root b squared minus 4ac. Do you guys remember this one? All over 2a, I believe. So this is our a, this is our b, this is our c. Let's try and plug it into this equation. X, well, sorry, it's not x. We're solving for t, right? So, sorry, t equals negative b. B was negative. Am I right? Hold on. Okay, sorry for that. I do believe I'm solving this correctly. If anybody notices that I'm doing something wrong, please tell me. But I'm just gonna continue plugging in my numbers. So we have positive, negative, root b squared, negative 2.5 squared minus 4a. A was 4.9. C was negative 3, all in the root, all over 2a. A was 4.9. If you plug that into your calculator, you should get 1.078. If you and you should get 2 because it's a positive and minus. So let me do that. Minus. The other solution would be negative 0.567. Hopefully, which one the answer is obvious to you. It's obviously going to be this one because a negative time does not make sense, right? So we don't have to think about that. So, oh, but a little bit of sig figs, right? So we have, how do you call this? Would it be 2? But anyway, the answer should be, you want to round this 8 up. So it'd be 1.08 seconds. That would be the official answer for this. Okay.